Hello and welcome to a new video on IGCSE mathematics. In this video, we shall be discussing interesting quadratic problems. These are the types of problems that came up in the past papers once or twice that weren't very often repeated. So let's start. The solutions of the equation x squared plus bx plus c equals 0 are -7 plus root 61 over 2 and -7 minus root 61 over 2. Find the value of b and the value of c. So in this case, the solutions look a lot like the structure of the quadratic formula. So if we try to write the quadratic formula here, a is equal to 1, b is equal to b, c is equal to c. So minus b plus minus root b squared minus 4, and a is 1, so we don't need to write a. So just 4c over 2a, and again, a is 1, so we don't need it here. And we can compare the solutions to this expression. We have 2 in the denominator, so we're okay. We have -7 here and negative b here as well. So -7 equals negative b. So basically b equals to 7. Finally, we have b squared minus 4c under the root, and this is equal to 61. So b squared minus 4c equals 61. 49 minus 4c equals 61. We can take the 49 to the other side. So negative 4c equals 61 minus 49. Negative 4c equals positive 12. Divide by negative 4. So c equals -3. In the last step, I just divided both sides by -4 to get the answer. So b is equal to 7 and c is equal to -3. Let's compare to the marking scheme, and it seems to be correct. B is in fact equal to 7 and C is in fact equal to -3. This is a graphing problem. We are required to sketch the graph of y equals x minus 1 all squared. Always be aware of where it cuts the x-axis and the y-axis. These are the main points that you need to be aware of. And in case of quadratics, it might be a good idea to consider the vertex as well. So a quadratic equation looks like this: x minus h squared plus k. And the vertex is basically h and k. So in this case, h is equal to 1 because we have negative h here and -1. So h is 1, and there is no number outside the bracket, so k is basically 0. So the vertex of the parabola is at 1, 0. This is important. Now to get the y-intercept, because the vertex is also the x-intercept, so you don't need to get the x-intercept anymore. So to get the y-intercept, you just plug x as 0. You have 0 minus 1 all squared, and this is equal to 1. So you also have this point here, 1. And this is obviously a smiling parabola because the x power 2 is positive. So the bracket does not have a negative sign outside. So you know it's a smiling parabola. So it looks something like this. So this would be y equals x minus 1 all squared. For b, you are required to sketch y equals half x plus 1. Like I said, you just need the intercepts to make this happen. So y equals half x plus 1. To get the y-intercept, you put x equals 0. So if we plug 0 here instead of x, we get half times 0 plus 1, which is basically 1. So the y-intercept would be 0, 1. For the x-intercept, you would put y equals 0. So you would get 0 equals half x plus 1. Take the 1 to the other side. Becomes -1, of course. So -1 equals half x. Multiply by 2, you get x equals -2. So we have -2 and 0. That's our other point. So we just go to the sketch, to the graph, and we have -2 and 0. So we have -2 here. So this is the first point. And 0, 1, this is the second point. And your line should look something like this. Now, In double I, we are told that the graphs intersect at A and B. So let's say this is A, let's say this point here is B. We want the distance or the length of AB. We already know that A is actually 0, 1. We need to get B. To get B, we need to solve the two equations equal to each other. So we have y equals x minus 1 squared and y equals half x plus 1. We equate them together. We get, let's expand this first to make life easier. So x squared minus 2x plus 1. And we say x squared minus 2x plus 1 equals half x plus 1. We take everything to the left, just get one equation equal to 0. So we have x squared minus 2x plus 1 minus half x minus 1 equals 0. Let's simplify. So you have positive 1, negative 1, they cancel out. So you basically get x squared, and then minus 2 minus half is basically minus 2.5x equals 0. You can just factorize x times x minus 2.5 equals 0. So either x equals to 0. If we're solving this, this tells us that x equals to 0. And this tells us here that x minus 2.5 equals 0 or x equals 2.5. We already know that x equals 0 is the first solution because we know that A has an x value of 0 anyway. But we now know as well that B has an x value of 2.5. How do we get the y value of B? We plug it into either one of the equations. So B has an x value of 2.5 and we want to get the y value. All you have to do is just plug it into either one of the equations. So if you plug it here, for example, if you put 2.5 here, 2.5 times half is 1.25, and then you add 1, so you get 2.25. You just plug it in, or you could have plugged it here as well. So 2.5 minus 1, that is 1.5, and if you square, you still get 2.25. So this is the point B, which we have on the graph here. Now we want to get the distance or the length of AB, so we just apply the distance formula. D equals radical 2.25 minus 1 all squared plus 2.5 minus 0 all squared. And you find it on the calculator. So 2.25 minus 1. That's 1.25. And then you square that. You get 1.5625. And then you add 2.5 squared to that answer. You get 7.8125. This can all be done on the calculator. And finally, you take the square root of your answer. And the approximate distance is 2.8 meters. So let's check the marking scheme. Thankfully, 2.8 is actually correct. Let me erase a part of the answer just so that you can see. .8 is in fact the correct answer. And that tells us that we are on the right track. I'd also like to draw your attention to the marking scheme in terms of the requirements of graphing. So for the quadratic, we wanted the minimum to be touching the x-axis. So this was important, and we already had that. And the vertex has to be at the bottom, so it has to be a smiling parabola. These are the 3 marks here. Excuse me, these are the 2 marks for this problem. And for the line, you needed to intersect on the y-axis at 0, 1. And it had to have a positive gradient and a positive y-intercept. So the x-axis, the x-intercept here was not awarded a mark. But anyway, it's a good idea to always find both x and y-intercepts. So this brings us to the end of our video. I hope this has been useful for you. Thank you for watching.